everyone. Thank you for coming. My name is Mengyun. I'm a researcher at the Imperial College London. And my research is about AI in healthcare, basically using computer science technology and find what is the best application in healthcare. So I want to tell a story when I started this research. So I remember back to 2015 when I started to do an undergrad and starting a project with my supervisor back then. I was a fresh student. I want to figure out what is going on in hospital. So I made a meeting appointment with a doctor in the hospital. I remember it was like 8 or 9 in the night. I don't remember the precise time, but it's really late. And when I went into her office, she's still doing those kind of like report writing and looking at those like MRI scans in her laptop. And I was like, why are you still working this late? And she's like, I have to. I need to see patients at daytime. That's the only time I got to write reports for every single one I meet today. And I can't finish it all if I don't work late till night. So at that point, I was saying, those are repetitive works. Basically like writing, okay, this tumor is round. The boundary is blurry, and this could be a sign for a malignant tumor. So these are basically repetitive work for a radiologist. And at that time, I would think, can I build a system to help those doctors to reduce their work so they can have more energy, more time to focus on what really matters, patient care. So during my PhD, I designed my first automatic system to help radiologists diagnose breast tumor from ultrasound images. So that's the starting point of me developing my own algorithm, my research in AI in healthcare. But that's not the whole picture of the AI in healthcare is definitely bigger than my story. So let's take a look at some photos. So who of the audience have been to the hospital to take those kind of scans? Like, can you give me a sign? Yeah, so okay, let me ask this question. Has anyone of you received the reports of these scans within 1 day? No. Okay, so you see the problem. So when patients have some signs, we need to diagnose it. We need to go to hospital to see what is going on in our system. We want the results to be back to us as soon as possible to avoid some delays, because those kind of delays, if you delay for a week or months, this could actually cause death to some extent. So what the AI can do or want to do is to design those kind of systems to empower the doctor to give better and quicker decision and diagnostic of patients. So these are like some photos, some MRI scans of brains, of eyes, of lungs, all kinds of organs. When you have some diseases, you need to have those kind of scans to see what's going on in the system. So that's the start. That's when the AI can work. So instead of detecting all these tumors or these abnormals using human eye, which radiologists tell you what is going on wrong, we design the system to see we can detect these abnormals for radiologists to save some of their time. So recently, Microsoft has published a paper in Nature Methods. They designed the system. They take this kind of like image as input, and you can give them text prompt, just like ChatGPT. So you ask the system, okay, can you detect lung nuclei in the CT scan? And the output text and tell you, okay, here's one. And they can give you the labels on the images. And also, if you give them wrong direction, like, do you have any infections? They will warn you, this is the wrong input. So let's take another example. So this one, we ask the system to get all cell types, and the system can give you the result instantly and marking all those cell types and classify it into different categories. So this is like super fast. Imagine if a human being need to mark, even with your mouse, to mark what kind of cells is this? It takes at least 5 minutes at least, but we can do it with AI system within one second. So with the technology developing so fast, our research is trying to bring in something new into this healthcare area. So we introduced the digital twin idea. So does anyone know what a digital twin is? Yes, okay, so it's really interesting idea. So when we're talking about digital twin, some people might get a bit confused. Is that something used in the, building a system, like a building or a car, a house, this kind of thing? How can we build a digital twin of human body? It's actually a digital replica of our human body, and it can evolve with time, just like us. So my research in UK is about analysis cardiovascular diseases, the heart diseases. So I'm building a digital heart model. So when you go to the hospital, you take a MRI scan, and we can reconstruct this kind of digital heart model from your MRI scan. And so next time when you go to hospital, instead of talking with radiologists, ask them what is going on in my body, you can actually see what is going on in your body. And with this kind of model, we can do a lot of things. The first thing is, since this digital heart can be generated from scratch, which means just like ChatGPT or Midjourney, you give them some text prompt. Please give me a image that cat is eating a cake. I'm also tell the system, can you give me a digital heart model who is like 60 years old, female, and tell the system the weight and height, and we can give a digital heart that aligns with your condition. So basically, this is our heart if we don't have any kind of diseases. So we call it a normative heart. So by comparing your heart with this normative heart, we can see the difference. And by looking at this difference, we can tell some potential risks. We can tell maybe you have the risk of having some kind of disease like hypertension, and also some cardiovascular diseases. So that's the first application. And another one is give some condition changing, like, okay, this is my heart right now. This is what you see from MRI scans. Can you tell me what my heart is going to look like in 20 years' time? This model can do. It can synthesize what your heart gonna look like in 10 years' time, 20 years' time, 30 years' time. So in that case, when you go to hospital, you say, okay, the radiologist thinks your heart has some kind of problem, but it might not hit the bar. They give you medication. So in that case, based on your clinical history, like your health history, should we give you the medication or not? It's actually a problem that really need to be careful about. So with this kind of model, we can try to give this digital heart some medication and say, okay, I'm gonna give this heart a medication. What is gonna change in 2 years' time, in 3 years' time? So this is something we can help the radiologists and the doctors to decide those difficult questions. And instead of the heart is only one of our projects. We're also doing a lot of other organs projects like brains, breast, lung. And although you might think, isn't AI a magician? Actually, no. We are studying AI, we're studying this kind of technology. We know it has its own disadvantages. So the first thing I can think about is the data bias. Some of you may know, we train the AI model based on the data we have. So imagine I build a model. If I only build it based on male hearts, would it be still accurate if you tested with a female image? If I only train it with the data set in the UK, would it work in India, in China? So this is kind of data bias problem we need to solve. if we want this model to be applied to be useful to everyone in the world. And the second problem is the privacy. That's actually a very important problem in our research because we are using data from real patients. We're training the model with real patients. We need to be really careful when we're dealing with the data to protect people's privacy. And actually, that's a problem we solved by trying to develop this model. So the generative model can generate a synthetic data set, like those ChatGPT, those Midjourney. It generates fake data, but also as realistic as real data. So when we trained the model with the synthetic data, we can protect people's privacy. So that's one solution of us. So as we can see, we are trying to use AI as a tool. We never want to replace doctors or radiologists. We try to give them superpower to help them reduce work and help them focus on what matters most. So imagine this world where no report goes unreviewed, no patients got delayed diagnosis. This is what we're trying to build, and this is what I'm working towards. And with the help of AI, it's actually closer than we think. So I can imagine if everyone have the needs to go to hospital, everyone might have some diseases in the future at some point in their lives. So I think what we are doing about this research is really meaningful in this sense. We are not just using AI to do some fancy work. We're actually using AI try to solve the real problem in the world, try to make this healthcare system more efficient and help everyone in this world. So the AI isn't just a technology. It's not just the models, algorithm, plain code. It's about people. We're trying to have a radiologist. They don't have to work every day till night. We try to help a patient who don't have to wait weeks, months for their results. And we're trying to save lives that can be saved if you can give them early detection and get this diagnosis earlier. There are definitely some diseases can be cured if you can give them treatment earlier and personalized. Thank you.